This exercise is to build a model to predict the electrical energy output of a company. So the model uh, requires a certain inputs, more than two inputs, and then one target output it. Since the model has a more than uh, two predictable inputs, so and then one output which is a target predictable one. So a multiple regression model is what I thought is that the right for building this model it. So this for predicting the electrical consumption, electrical energy output of the company. So we have a four input parameters, which are a temperature, ambient pressure, relative humidity, exhaust vacuum. Once we give these inputs to a model, it will give us a electrical energy output PE. So we have a sample data uh, which has around 9,559 records it. So for our building the model to show it, I'm going to pick up a first 15 as a training database, a rest 5 records for validation, so that I have separated out my training data set as well as a validation data set. Uh, so I have picked up the data regression uh, uh, from the data analysis feature of the Excel, and within that I have picked up a regression as a model to build it. So I'm picking up a regression. Once I select it, it will ask me to provide a input for the X as well as the Y. Y is which is the predicting which is the uh, actual data that I received from I received, and I have it, and the X is the input variables. So once I give input, uh, which are uh, uh, which are the four variables, I'm going to get a output in the form of five, which are the real data that the factory has given me, where the sensors have emitted it. Now, if there are the labels included, I can include the labels, and then I can output the model into the location I've given. And I need to also select residual, and then the rest of the value remains same. Once I select it, so it will give me the data. And if you see which is significant for is the R square, where it is supposed to be more than 9, that means that the model which we have selected is working fine for us. And another important thing, values we need to see the coefficient. And if you see the slope is a 70, and the coefficient for the variables are ATV, and you can see it here. In order to build the model, which is a y is equal to coefficient into the input plus the intercepted. So I built a model which is you can see with a formula, and then I provided a first try. I will provide with the first training to see that it is giving the values. Uh, it is meeting the values. So if you see, I got a 464, and which is a targeted energy output I'm given. But let me input the values of the target data set and see what the model is giving. The model is giving a 459, which is 460, and which is close to the actual value. That means that model is building it. Let us check with another value, another set of data. So the model is giving 464, which is a 460. So the validation data, when we give it to the model, which is close to the actual values that we have it in the sample data set. Now, let's see the same data with another model, which I again use the Excel sheet feature of a scatter plot, where I plotted the input and the output variables which I received from a sample set, which is an actual values, and I plotted it using a scatter plot. And you see that the R value is zero point 0.8, which is less than zero point 0.9. Um, if I compare the both the models, the regression model is more efficient and the close to the actual values. That means that we should consider using the multiple regression model for uh, this kind of requirement. With this, I conclude my presentation. Thank you.